Objective 2.10, Modeling with Polynomial Functions. So our goal with this lesson is to be able to write the cubic function when given a graph or information about the graph. So here's our first example. We can see from the graph that we have a cubic function. We can see where the x-intercepts of the cubic function are, and we can also see another point, which is the point 1, 8. So our x-intercepts are -1, +2, and +3. And so from that we can come up with our factors for the function, which will be x plus 1, x minus 2, and x minus 3. But what we're not really sure about at this point is what that leading a value should be. So that's where our additional point comes in handy. What we do know is that our graph has to go through the point 1, 8, which means it has to have a y value of 8 when I use an x value of 1. So I'm going to use that in my equation. I'm going to put 1 in for each of the x variables, and I'm going to put 8 in for the y. So that now the only thing left to solve for is a. So I'm going to simplify each parentheses so that I'm looking at 2 times -1 times -2, which gives me a 4. So I now have the equation 8 equals 4a, which means a would equal 2. So now I go back to the factored form. I put the 2 in for a, and my cubic function will be y equals 2 times x plus 1 times x minus 2 times x minus 3. And at this point I'm really only looking for the factored form of the cubic function. I do not need you to multiply this all out and make it standard form. Now sometimes we're not given the graph of the cubic function, we're just told some things about it. So in this case we're told excuse me, that our cubic function passes through the points -4, 0, -2, 0, 1, 0, and then 0, 8. Now what you need to tell from this is that these first 3 points where the y value is 0 are all x-intercept points. And so just like we did when we could see the x-intercepts on a graph, we're going to use these x-intercepts for our factors. We can also identify that 0, 8 is a y-intercept. So using our x-intercepts as factors first, we would have x plus 4, x plus 2, and x minus 1 as the factors. We have an a value out in front of that we don't know right now, and then all of that should be equal to y. Now in this case our y-intercept is really just another point. So we know that when x is 0, we should get an answer of 8. So we put that into our equation, put in 0 for all of the x's, put in 8 for y, and now we can solve for a. So each of my parentheses becomes 4, 2, and -1, which when I multiply them all together becomes -8. So I end up with the equation 8 equals -8a, and therefore a would have to equal -1. So my final function for this situation is going to be y equals -1 times x plus 4 times x plus 2 times x minus 1. Alright, why don't you give one a try? Here's some information about a particular cubic function. Take a moment to see if you can come up with the actual function, knowing these points are points that your cubic has to pass through. Pause the video for a moment while you try it and come back when you're ready to answer the question. All right, so again, our first 3 points are giving us x-intercepts because the y coordinate is 0. So using those x-intercepts, I get x plus 2, x plus 1, and x minus 5. Then my negative 3 comma negative 8 is my additional point. So I put in negative 3 for all of the x's and negative 8 for the y so that I can solve for a. When I work this all out, I end up with an equation of negative 8 equals negative 16a. Make sure you are dividing in the right order. Sometimes we get messy and we don't concentrate on what we're doing and we look at negative 8 and negative 16 and think we should get 2. But that's not dividing in the correct order. We are dividing each side by the negative 16 so that we get a by itself, and that leaves a as 1/2. So our final answer here is that y equals 1/2 times x plus 2 times x plus 1 times x minus 5. All right, so that's really it for this last lesson. It's a fairly simple one. It's a fairly short one. Keep in mind that when you see the information about the x-intercepts, we're going to assume that the x-intercepts have a multiplicity of 1 and that we are dealing with just a cubic function. So you don't need to get any more complicated than that. And that should be enough information to get you through your practice problems for the 2.7 practice in your book. If you have questions, go back and rewatch the video or find other resources to help you answer those questions. Make sure you check your answers on Canvas when you are done. And we'll be wrapping up our chapter here soon with another quiz and then our test in just a few days. Don't hesitate to email me if you have any questions or concerns. And we will see you in Chapter 3.